that was,
But we had those research things that we did in class. Those were fun.
yeah, that was from my idea.
Yeah.
Yeah.
Those were fun. Sometimes I would like, what does this have to do with childhood development? And then we bring it back in, like, aha.
Yeah. Are we okay? That did work. Awesome. Yeah. I think I've run out of videos. I don't know if I have a funny video for you guys today.
Funny story.
Thinking. I told you guys about my brother-in-law, right? About that prank. Wait, and I told you guys about
I don't know if you told that one in this class. I know you told it in the class I was in.
Oh. And I told you guys about the rat one, I'm sure.
Yeah, you did.
That was in this class.
Yeah, the prank with the
Yeah. It's like.
Do you guys know that we don't have class on
Tuesday is a state holiday,
Yeah.
which not all my schools are honoring, which is annoying. So I'm still working, just not as much on Tuesday.
Because I don't even have work on Tuesday because the people I nanny for, the mom's a professor and she has off too.
Yeah.
And she's like, oh yeah, you don't have to come in. So I'm like, sweet, I don't have school, I don't have work that day, I can study.
Jackie, you're here. Lewis, you're not. Hector, you're here. Marina, you're on Zoom, which is fine. Nikki, you're not here yet. Okay. Alicia, no. Vicente, not here. Ariel, where's Andy? Michelle.
Small class. Okay.
Godiva. So you guys want to just jump into worksheets, or would you like some context on? Okay. Oh, okay. So the PowerPoints are helpful.
It was confusing when we started doing the homework for chapter 8, and I'm like, wait a minute. So then I'm like going through the PowerPoints, I'm like, aha, that's where that is.
Okay, yeah, we can do that. That's fine.
I wanted to do something different. She upset. We did it, and now we know. You upset me that day. So what do you mean? No power. Well, nobody spoke up. No, we tried it, and now we know. No, yeah, it's not like it's not. No, we're not going for it.
Admit. Okay. Got it. Mic check, mic check. You guys can hear me? Yes, you can hear me. Okay, perfect. Perfect.
We have a small class today.
Well, we got Marina. And we have 5.
Oh, okay, I didn't see how many people were on Zoom.
It's still pretty small.
We didn't have that many people in my other classes.
You know, this is the second best community college in the country, by the way.
I believe it.
I teach at another community college.
I know that the college has like one of the best 2-year nursing programs in the country.
Yeah, I don't know who the best is in the country, but they are the second best.
Yeah.
That's pretty cool. Student resources.
We have a lot of programs here. So many programs.
Yeah. It's pretty amazing. But starting with 9 would be okay at this point, Esther, because I think we're kind of already taken the exam, right? You're good on 8 and the review helped and everything. Okay. Chapter 9. My grad stats course got all moved over wrong. My boss is kind of angry earlier. It was fine. We were actually cursing back and forth. No one was mad. We were just trying to figure out the problem like a couple hours ago. Can you guys see? You guys can see, right? Zoom folks. Should be sharing correctly. You got to tell me if I'm not.
Yeah, I can.
Oh, is math red or blue? Ooh. Red.
I think red.
It's
Yeah.
either red or the color is like green.
That came up in Gen Psych just now. I'm like, what? It's red for me because I learned it when I was really little.
See, I was homeschooled, so it was whichever color I hated the most.
Oh, it's red.
But.
Oh, yeah, blue is
I-
math.
I don't
Blue
hate
is
math.
math.
I hate red.
Green is science, English, like language arts is red.
Yeah, there we had quite a discussion about it like last.
That's true. Every other person I talk to though, they say that math was red, and I think English is blue.
Yeah, there was quite a debate about it. I never heard my Gen Psych class be so loud till today when they. It was a weird interview question for the mock interviewing.
It's such a weird thing. I don't know if it's like,
Why'd you here?
Whoa.
Well, all right.
I don't know why that's such a big debate.
So you want to tell us, you want to weigh in on this before we start? Is math red or blue?
Is what?
Is math red or blue?
Blue.
Blue. Okay.
Yeah, I'm with the audience. I think it's red.
It's red for me.
I also think it depends on what color my book is too. Because sometimes I correlate the book with the folder. so
Okay.
I know which one it is.
So we're gonna go from Z to T. Talk about degrees of freedom. Reading the T table, one sample T test, effect size, two independent sample T test. Effect size or two independent sample T test, and then how we report it. Not a big deal. We will get through all of this. So you remember the Z obtained score? We're gonna do the T obtained score. It's very, very similar. I have markers if we need them. Or I can draw poorly with the mouse on the whiteboard. To compute a Z obtained score, population variance must be known. In behavioral science, it's rare that the variance in a population is known. So Gossett proposed the T-score. We substitute the population variance with the sample variance in the formula for the standard error. The substitution, called the estimated standard error, is the denominator of the test statistic for the T-test. This is acceptable because sample variance is an unbiased estimator of the population variance. We're going to do worksheets that really walk you through it. So don't freak you out, or if you have questions, feel free to ask. So the estimated standard error is an estimate of the standard deviation of the sample distribution of sample means selected from a population with unknown variance. Is an estimate of the standard error or standard distance that the sample means deviate from the value of the population as stated in the hypothesis. So the standard error, SM, is equal to the square root of S squared over N, which is equivalent to the standard deviation over the square root of N, which should look familiar from before. I wish we had a camera so you could see them too, Marina. Okay, so.
It's okay.
So using the substitution of the sample variance for the population variance, a new test statistic is introduced. The T statistic, pretty similar. T obtained value is the mean minus the other mean. So like the sample mean minus the population mean over the standard error. This is used to determine the number of standard deviations in a T distribution that a sample deviates from the mean value or difference stated in the null. So it's almost identical to a Z score, but it's a T score. Very, very similar. So T obtained value is equal to over the standard error. Remember, this would be the variance. So using the estimated standard error in the denominator of the test statistic led to a new sample distribution on a T distribution. It is a normal distribution with greater variability in the tails. So if you look, you can see Here, your normal distribution is at the top, then your t-distribution is a little bit above that. Distribution, so the tails are thicker, which reflects greater variability in values resulting from not knowing the population variance. You can also notice the normal distribution has less variability in the tails. Otherwise, the distributions share the same characteristics. C-score versus T-score. I don't even think we're at published worksheets anymore, by the way, at all. So the degrees of freedom for a t-distribution are equal to the degrees of freedom of the sample variance. You probably remember n-1, that was degrees of freedom. As the sample size increases, sample variance more closely resembles a population variance. The degrees of freedom of the sample variance increases, the shape of the t-distribution changes, the probability of outcomes in the tails becomes less likely, and the tails approach the x-axis faster as the n or the sample increases. To locate probabilities in a t-distribution table is used. Use the t-distribution and critical values in the table to compute t-tests. You need to know n alpha level, which is like right here, and the location of the rejection region. If you all have your books, I would probably find this in there, just so you're familiar with it. That should be like Appendix D, Appendix E. I believe, C2, Appendix C. Electronic, it should be basically right after the z-scores, you should have t-scores. I believe I also posted that too. And like, remember that z-table from week 6? I'm pretty sure this, if you continue to scroll down, there's the t-scores.
Do you have control over how many web assignments we get?
Yep,
Like you can add more assignments?
I could.
Can you?
I usually don't though. Because it would wreck my syllabus.
Yeah.
So what it is, it's a bank of questions. I can give you more time.
No, not more time, like more assignments. But they're 3 points.
Can't do that. Would wreck this.
Easier than I think they're easier than like the stuff we get on Blackboard.
I'd have to change the syllabus. I couldn't just give you 3 points. I have to change the syllabus. That wouldn't really work. I mean, I could change the syllabus, but then
You have to check with them, the board and everything.
no, that's my academic freedom. But the problem is if I change the syllabus, then it wouldn't help you. It's better just to take it 6 times for the material because
why?
it's a bank of questions. It's like 135 questions and you all get different ones for each chapter.
Why do you have to change syllabus if you want to add more assignments?
Because the administration knows what I'm grading you on, so I have to change the syllabus.
Oh.
And then they check and they look at the syllabus. Like I create the syllabus, but if I try to it's easier to modify it for next semester at the beginning of the semester than to try to modify it now. It's not impossible. It's not etched in like stone. It's just it would be problematic. I would say just practice the worksheets more. If you want to resubmit stuff, I'll work with you.
No.
Do you need more attempts or something?
No, they're good. It's just like I like they're easier. So that's just me. I would prefer to have more web assignments because they're easier.
Oh, my worksheets, you actually get the material. I appreciate the feedback, but it's stats. There's going to be some.
Yeah, I think worksheets are more effective.
Like I want to make sure you get it. I feel like WebAssign is really good practice, but I feel like the worksheets
Bro,
teach you
I'm
what's behind
thinking-
it.
I'm thinking
I hate web assign.
they're so much easier.
I think I like web.
I think that the worksheets are easier than website.
All of a sudden they show you where in the book
I don't hear that.
and you get more time.
It's that's true. It's good practice. It's just not my favorite homework to submit.
Okay, well, we're mixed. So one sample t-test, a statistical procedure used to test hypotheses concerning a single group in a mean population. 3 assumptions of normality, so that's that bell curve, assume the data in the population are normally distributed, so normality, like literally bell curve. Random sampling, so we grab people randomly. Where's your friend? Any idea where Andy is or no?
Did he come last week?
He did. I don't think you did, or no, you were on
No.
Zoom.
Last 2 weeks I was.
Yeah. And then your independence, assume the probabilities of each measured outcome in a study are independent for the one sample t-test. Don't worry, we have worksheets. So everyone have this so far? Is this making sense? Just conceptually, it doesn't have to all make sense immediately. So what is the difference in the nuance? Well, in a Z statistic. A z-test, looking for a z-statistic or the probability value. T-test, same thing. What distribution is used to locate the probability of obtaining the sample mean? Z-test, normal distribution, t-test, p-distribution. What is the denominator? Well, a z-test is the standard error. T-test is the estimated standard error. So they're very similar. We know the population variance for a z-test. We don't know it for a t-test. Degrees of freedom are not required for a z-test. They are required for the sample variance in a given sample, which is always n-1. Degrees of freedom is always n-1. What does the test measure? The probability of a measured sample outcome. What can be inferred, whether the null hypothesis should be retained or rejected. So a lot of the same critical value, we're going to see where it falls. So Elbert, Salvi, Sirocco, Bogetta, and Mina study relatives of patients with obsessive compulsive disorder, OCD. Social functioning of relatives was recorded using a 36-item short form health survey. Scores range from 0, worst possible health, to 100 best health. The mean was 77.43. Mean was 7.43. Suppose researchers select a sample of 18 relatives. What do they just tell us? N 18 were equal to mean social functioning score of 62 plus or minus 20.94. So we all know that's our sample mean, and we all know that's our standard deviation. Right? Makes sense? Everybody? Suppose research, so they did that, and then we're going to test whether or not the mean score in the sample differs from that of the general population of 0.05 level of significance. So first, state the hypothesis. The mean function score is 77.43, the same as that as the population. So it's equal to 77.43. Or alternative hypothesis, the mean is not equal to 77.43. Then we're going to set the criteria for the decision. Level of significance is 0.05. Since n is 18, n-1, so the degrees of freedom are 17. To locate the critical values, and let's do that as a group. For the cutoff, look for the t distribution equal to 0.5 and the two tails combined. Find 17 listed in the rows table B and appendix B, and go across the column for 0.05 in two tails combined. And the critical value should be plus or minus 2.110. That would be fine. 2.110. Or if you'd like, I can screen share and tell you where that came from. Did you guys find it? Are you looking? Does that make sense? You missed the other announcement. Abnormal psych next semester if you were interested. I have abnormal psych next semester if you want to learn about schizophrenia and bipolar and all kinds of mental illness. You're welcome to register.
If it's under normal class, yeah, I'll use it.
If it's a normal class,
You know, if I have to take a class under, what does go under? Regular psychology?
it would probably be like regular psych or liberal arts or elective, depending on what you need. Or maybe a little like soc.
If I need it, okay.
Yeah, just scroll down. Or we can look at it together if you guys aren't seeing it. So let's go into, it should be the Z-scores. I'm pretty sure student resources. No, chapter 6. Because I think I posted it. So why don't I?
It's there.
You gotta scroll down for a while.
Yeah, and then you have the degrees of freedom underneath that. What were we looking for again? What number?
2.110. So I'll show you. I'll show you Zoom folks where we're at, and everybody else. We'll just screen share. So this is our Z table right here. Did that work? Maybe. Okay, so where do they get that from? Degrees of freedom 17, right here. And then we're looking for the 2.110 that they found was the proportion of proportion and two tails combined. So that's right here. And then it was the 0.5 alpha level. So it was this against the 17 because it was n-1. That's where they got that from. Because it was like that. Does that make sense? Okay. Zoom folks, does that make sense? Give everybody in the class that makes sense how we found that? Okay. Let's go back to our,
Do you get a notification when anyone drops a class?
yeah, I get an email. The administration. I get like a PDF file for adding or dropping classes. But now if the class is full and you want to get added late, you have to crash my course for like a couple sessions before I sign you in now. That's the
Yeah.
thing that I'm doing.
Remember,
I'll sign you in early, but if you want to come, the class is full, you want to get added late, you have to come to class a couple times so I can see if you're awesome and mature or not. Because if you're gonna like not behave, then I won't sign you in. If you're last minute. If you're last minute, because I don't know who you are.
Yeah.
If one of your friends is like, oh, Dr. Mack's awesome. Because there was one person one semester, a couple semesters ago, that was like, could not behave. So now I make you wait if you try to come into the class last minute.
yeah, in the beginning, you were worried that they wouldn't have this class because there's not enough people. Let's say, do you remember?
Oh, yeah,
That
yeah.
that happened last semester with my class. I actually had this, like this class last semester and they had to drop it.
Yeah. If there's not, usually there needs to be about 10,
Or 12, right?
usually at least 10.
If so, if people.
I can't email you guys. I got in trouble for that one.
Yeah, what?
I can't email you guys anymore if that happens again. I have to just hope my classes are full.
What if
Someone in the administration doesn't like it because somebody called the administration through me on the bus.
oh,
Yeah.
What if people drop the course and it goes under 10? Do you still have the class?
If it's a graduation requirement, yes.
What if you've already started? If you've already started.
If already started, it doesn't matter, but if it goes below, usually the magic number for the class to run is like 4 for the university to like break even. And most schools to like not lose money. If there's too light, they will cancel it. Your class was canceled.
Yeah.
Welcome to being an adjunct. It's a hard knock life. Good expletive luck. Something like that.
I've had classes where they canceled because there's 9 people.
Yep.
And then I have a class currently that only has 4 people in it.
Oh, wow, we were taking that.
Yeah.
During the summer, but then I couldn't get it.
Yeah. Because there's not enough registered at the school. So you have to pay for the lights, they got to pay professors, they have to pay all these things. So usually fuller is better. I like smaller too.
Yeah, the smaller classes are more fun. Like I've had classes with like 8 people on this one. I don't know how they got 8 people and not 10, but
If you all needed it to graduate, they look at like your like trajectory. It'll hold even the smaller classes, but usually it's about 10.
Do you know who?
I like to have students come into other classes because that gives me a little job security. Like I love you all, it's still, I'm honored to see the same faces, but also if like 4 or 5 of you like re-register for a course, now I need 5 more to make sure the class is full enough. Because they will yank the class.
Did they tell you who threw under the bus?
I know through me because she emailed me,
No way.
so I know who it is. Yeah,
She told
Are
you?
you serious?
she told me, and then I got an email that a student called, but the student emailed me and was like, I called and your class isn't being canceled, blah, blah, blah. And then I got an email like a day or 2 later.
Oh.
That's a student called the administration about the emails I sent from Mexico. So yeah.
They didn't intentionally do it though.
What?
They didn't do it like with intention.
No, they totally intentionally did it.
You said they were asking to see who's gonna be canceled.
Yeah, and they're like, don't. So I didn't really get like in trouble, but they were like, this is when your deadline is when it's a 12-week class. Because we're a 12-week class, so I actually had more time than I thought, and it did fill up. I thought it was the same as a 16-week class for when it would get
Wait.
dropped. I was just trying to survive. I was trying to make sure I had enough students in my
Is
class.
this one?
No, it was a different
Why was
class.
she mad though?
Because apparently I was causing stress to students by emailing you guys to try and keep my class full. That I shouldn't be doing that. Oh, I'm not like, my job's not in jeopardy. I just got like
No,
slapped on the wrist.
Okay, what? You guys-
No, I didn't get written up. I just got an email, don't do that anymore. You shouldn't be doing that. Let me explain the policy to you and when it actually would have been urgent. So she kind of was, it was kind of like vague, like
But did that student not like, did you film it or?
I don't know. I don't know why she called.
Was it great in the class?
I can't tell you that because of the Family Education Rights and Privacy Act.
Was it good one or bad one?
I'd have to look. I don't remember.
Okay, wait.
I could probably tell you if that student failed or passed, but I couldn't tell you who she is.
Oh, yeah.
I could probably look that up, like not, obviously not on Zoom where it's recording, but I could probably figure out who that is and I could be like, I know this person got a certain grade, I just couldn't tell you who it is.
Oh, yeah. Man.
Because I can't tell anybody, like even if like your parents call, unless you sign a waiver, I can't, even if they're paying tuition, I can't tell them how you're doing in the class.
Maybe.
Yeah.
What was the crazy-
Great. She was mad.
I don't know, it's Gen Psych's kind of hard to flunk unless you don't do the work. I flunk people every year.
That's the one I was.
There are people failed in your course last semester.
It was so easy.
If you do the work, it is pretty easy. There's a lot of work. It's a robust course. If you don't do the work, it's just like this course. If you do the work and the website, even though I know some of you love it or hate it, you're probably going to be adequately prepared for the test. Usually, at least here, if someone fails, they didn't do all the homework. They didn't take a test. Usually they drop the ball. Like someone got mad at me like a couple semesters ago for failing this course. That person rocked 400 in the class. You need over 800 points. That's less than 50%.
How many?
So it's not that you fail students, it's that
The students fail themselves.
by not doing the work.
I would prefer to give A's and B's, but it's whatever grades you earn.
How many points did we have right now?
I think. So there's 870. 870.
Like 300, right? No, 330, 320.
Shows you like colors, what grade you have, whether you have an A,
Yeah.
B, or a C.
It shows you in Blackboard, but Blackboard might lie to you. It's based on what the syllabus
Right.
says. So there's like 180 points for WebAssign total. There's about, I think 170 points in worksheets and review. And then there's the exam points, and that all adds up. And then it's percentages of that. So you should probably be at least 400 or 500 points at this point. Cause
No,
we're
no,
like,
it's at a 330. Out of 330. Wait, no, my grade was updated. No.
WebAssign I have to import. So if you have WebAssign points, they're still coming in for you. And then if you took a test, the test grade doesn't always show up in Blackboard until I go through and manually hit save for the points. So if you're in like the 300 or 400 range and there's some pending stuff, you're probably okay. If you're like at like the 100, 200 level range right now, you probably need to get some stuff in.
Yeah.
Or you may be failing, just as like a general statement. Step 3, compute the test statistic. So compute the sample mean and standard deviation from the information provided in table 0.93 or previous slide. So mean is 62, standard deviation is 20.94. Do we know where that came from? That makes sense. Define this test statistic, compute the estimated standard error and substitute the values for the t. So this is your standard error is equal to standard deviation, which we have, divided by the square root of n, which is 18, 4.94. Find the t statistic by substituting the values for the sample mean, population mean, stated in the null hypothesis, estimated standard error. So we take the t obtained value, sample mean minus population mean over standard error, 62 minus 77.43. Always do numerator, all of it, then denominator, aka PEMDAS, is equal to negative 3.126. So what does that tell us? Do you remember what we had? Right? We had plus or minus 2.110, and we got negative 3.126. So we would decide whether to reject or retain the null hypothesis, compare the obtained value to the critical value we looked up. So the t value was, t obtained is negative 3.126. That falls beyond the critical value of the lower tail. So we're going to reject the null hypothesis. So very much like the z-score. Does that make sense so far? Walking through it. We're going to practice with worksheets in a moment. So conclusion, APA format, social functioning scores among relatives who care for patients with obsessive compulsive disorder, mean is 62, were significantly lower than scores in the general healthy population. T 17 minus 17 is equal to negative 3.126. P value probability is less than 5% or alpha value. So far, so good?
Yes.
Okay. or the worksheets will make it clear, or ask questions, okay? I think I actually have the same or a pretty similar example on the worksheet where I show you the steps. To estimate the effect size in the population, the effect size is computed typically only calculated after finding a significant effect, reject the null. Three measures of effect size, which we have on the worksheet, by the way. Estimated Cohen's d, ETA squared, which is your proportion of variance, or omega squared, which is also a different way of looking at proportion of variance. Can everyone find table 9.4 in your book? That tells you what to do with Cohen's d, I'm pretty sure, without off memory. 1.4.
Yeah.
Should say like small, medium, large effect size.
Yeah.
So that tells you basically the significance of what it is you're comparing. Like, is it a small deal, medium deal, or a big deal? Makes sense? Just like vernacularly.
You don't mean that it's like smaller than small.
Yeah, trivial, like you can't really do much with it. There's something happening. Medium, like, is a bigger deal. Large is like these things are super related to each other. So estimated Cohen's d, measure of effect size in terms of the number of standard deviations that the mean scores shift above or below the population mean stated by the null hypothesis. The larger the value of d, which we just looked at, the larger the effect. So d is equal to the sample mean minus the population mean over the standard deviation. So example 9.1, 62, 77.43, 20.94. So we subtract those. So we plug these into this, and we get negative 0.74. Relative carrying for OCD patients reduces mean social functionings by 0.74 standard deviations below the population mean. So we're talking about how much the effect of the OCD affects people caring for those with OCD. Make sense? Ish? Or okay. Then we have proportion of variance, measure of effect size in terms of the proportion or percent of variability and dependent variable that can be explained or accounted for by a treatment. So the variability explained over the total variability. I think we practice that too on the worksheet, I'm pretty sure. So the treatment is any unique characteristic of a sample or any unique way that a researcher treats a sample, can change the value of a dependent variable and associated with variability in a study. So here's our ETA squared. N squared is equal to T squared divided by T squared minus degrees of freedom. ETA squared tends to overestimate the proportion of variance explained by the treatment. Omega squared is a more conservative estimate. And the only difference is it's W squared, which is omega squared, is equal to T squared minus 1 divided by T squared plus the degrees of freedom. Remember, you always want to do maybe some double brackets, all the numerator over all the denominator, or your score is going to look whack, okay? So for example, the one we just did, proportion of variance in example 9.1, ETA squared referred to the formula in the previous slide, which was this one right here. Okay, at the top. N squared is equal to negative 3.26 squared divided by negative 3.26 squared plus 17, and you should get 0.36. Therefore, 36% of the variability in social functioning, the dependent variable, can be explained by the fact that participants were relatives who care for patients with OCD treatment. How much did it vary? How much variability affected them? Same explanation for omega squared, but you substitute W2 value for the current ETA squared value, which is a more conservative rather than overestimate. So this is, yeah, trivial, like nothing. Small, a little more like reportable, like it's a bigger deal. Medium, like mid-range, and then large effect. You could think about this another way. You could think about like maybe like a mnemonic device, or way to remember might be like political attitudes, like conservative to like liberal or moderate being like the medium. I don't know where conservative, I would probably say maybe conservative or trivial or small, and like liberal would be like bigger deal, maybe. Or flip that if you're somewhere else on the political, you know what I'm saying? Like, I'm just trying to give you like a way to remember it, okay? That totally confused you.
No, it's funny how, I noticed that even through last semester, man, you tried very carefully. It's great.
Of course I do.
You know what I mean, right? Like,
Like not step on toes.
no, what? No, like if he says something that like may even like leans to a political like side, you're like, oh, no.
Or flip it.
No, that's great.
So a 2 independent sample t-test. So we just did the one sample. This is a statistical procedure used to test hypotheses concerning the difference between 2 population means where the variance in 1 or more populations is unknown. So you make comparison between 2 independent groups. Okay, back there? No question. Independent samples refers to the selection of participants such that different participants are observed one time in each sample or group. So let's look at an example. 4 assumptions are made. Formality, that's that bell curve, random sampling. We grab everybody sort of randomly. Independence, each outcome is independent. One outcome is not influenced by any other outcome. And then equal variances, assume that the variance in each population is equal to each other. This is satisfied when the larger variance is not greater than 2 times that of the smaller variance. That's when we know that it'll work. If it's not 2 times larger. We're going to practice. So for example, 2 independent sample t-test studying. Here, just make sure no one's on Zoom. Okay. No, we want to go back. Wait a sec. Study examining strategy to reduce food intake by eating slower. The test is 2 groups are given the same buffet foods to consume. One group is instructed to eat fast. The other group is instructed to eat slowly. Calories consumed in the meal is recorded. So we have these 2 groups. How much are they? Group eating slow or group eating fast? And then we test whether the rate of eating influences the consumption using a 0.05 level of significance. So we have our 2 different means. And our standard deviation is just the number of calories that we're measuring. Make sense so far? Okay. So you state the hypothesis. The null states that there is no difference, and the alternative states that the difference is greater than 0. So you'd write null hypothesis H subset O is equal to mean 1 minus mean 2 is equal to 0. No difference, rate of eating has no effect on the number of calories consumed in the meal. Or alternative hypothesis, mean 1 minus mean 2 is not equal to 0. Rate of eating has an effect on the number of calories consumed in a meal. Does that make sense? Okay. You're just tired, huh? Your eyes look. I feel like I've been at it since 8. This is my 8 to 10 day. So if you, because you're exhausted, if you want me to re-explain something, just talk to me. If you're like that just sounded like Charlie Brown, just tell me. It's fine. Yeah. So I've been there. So the criteria for a decision, the level of significance is 0.05. Since alternative hypothesis is a not equal to statement, you compute a 2-tailed test rejection region in both tails because we don't know where it falls to the left or right. We don't know if it's greater than or less than. We're just saying it's not equal to. Makes sense, right? 2 tails. To find the degrees of freedom for 2 samples, add the degrees of freedom in each sample. It can be found through 1 of 3 methods. Method 1, degrees of freedom for a 2 independent sample t-test, degrees of freedom 1 plus degrees of freedom 2. Or method 2, degrees of freedom for 2 independent sample test, N1 minus 1 plus N2 minus 1. Or degrees of freedom for 2 independent sample test, N minus 2. Then we have this chart on the bottom in terms of, it looks like, again, we're going to practice on our worksheets in a moment here. Yeah.
Like adding more steps to it.
Any more steps to it, and it's all pretty similar. Even when we get as far as like F scores, which is like the last chapter, we're just looking for rejection regions or acceptance regions of the hypothesis. You could use this in the real world if you're trying to prove something's working. Like something that you're doing at work, for example. Step 2, degrees of freedom is equal to 5 plus 5 is equal to 10. Locate 10 degrees of freedom in table B2 in appendix B. Move across the column to find the critical value for 0.5 proportion and two tails combined. Critical value for the upper test is plus 2.228. Does everyone see that in the T table? Or do you want to do that together? Where we got the T from? We are. Are we good? Is it making sense? Okay. Zoom folks, feel free to jump in anytime, okay? So we're gonna compute the test statistic.
Okay.
To compute the test statistic, we must find the estimated standard error. So we take SM1 minus SM2. So we calculate the pooled sample variance, which serves as the numerator for SM1 minus mean 2. Sample mean 1 minus mean 2. So an unequal sample size, you use the formula at the top. In an equal sample size, use the formula at the bottom. We are going to do a worksheet. I can't remember, it's this computer that's running it. Compute the test statistic, compute the pool sample variance, substitute the sample variance and degrees of freedom for each sample. So we get 20,500 by plugging our numbers in. Compute the estimated standard error. So we substitute the pooled sample variance, the sample size in the formula. So we take the square root, adding those two together, we get 82.66. Compute the test statistic for the two independent sample variable. Substitute the mean difference, observed 600 minus 650 is negative 50, which comes from that chart in that table. The mean difference stated by the null, mean 1 minus mean 2 is equal to 0. And the estimated standard error for the difference sample mean 1 minus mean 2 is equal to 8.82.66 in the formula. Therefore, mean 1 minus mean 2, 50 minus 0 divided by SM sample mean 1 minus mean 2, 1.70. T obtained value is negative 0.0605. Therefore, compare the obtained value to the critical value. So it was inside this time. So we retain the null hypothesis. Like you said, Jackie, it builds. Does that make sense, everybody? At least conceptually, we're going to do a worksheet with all the steps. Effect size for the two independent sample t-test, similar to the one sample t-test, and effect size is computed to determine how big the effect size is. Again, the same thing, three measures, estimated colons D, ETA squared, omega squared. Estimated colons D, place the difference between the two sample means in the numerator. So mean 1 minus mean 2, and the pooled sample variance standard deviation in the denominator. The pooled sample standard deviation is the square root of the pooled sample variance. Proportion of variance is calculated using the same formula for one sample and two sample independent t-tests. That's our ETA squared that we just looked at before. N2 is equal to t squared divided by t squared plus 2 degrees of freedom, or omega squared for the conservative estimate. W squared is equal to t squared minus 1 divided by t squared plus 3 degrees of freedom. When reporting the values of a t-test, you must include the value for the test statistic, degrees of freedom, P or probability value. In addition, a figure or table is often used to summarize the means and standard error or standard deviations. Cohen's D is the most reported with t-tests. That is the end. So now we're on to worksheets.
Wait, we're doing 2 chapters today or 1?
Depends. It's only 7. 1 or 2 or 1.5 or just 1. We only have 4 more chapters to cover.
How many worksheets are in this chapter?
I think 2.
We're only gonna do 2 today?
I probably will do 9 and 10 if we have time, because then we only have 11 and 12. Because I have an exam 3 review, by the way, that goes through all the stuff that we want to have time to go through also, which could take a class period or half class period. Probably half, realistically. At least that's what it took in the past. So I need to stop sharing. Stop share. Then I need to reshare in just a second. time would probably work. Like this, and then let's go like this, and let's go student resources. In-class activities. And then. There B. That's what I want. 9 and 10, no. And I think maybe it's here. No, it's not there. This is it. That's it. Yep. Okay, so we'll go back. Right. No, it's not it. What the hell was that? It's part B. I think it's part B. Yeah, so we're gonna change that. We're gonna go make this in-class activities week. Eleven. 3. Is that right? Yeah, this is what we call it.
At least that's what that's for G20.
Yeah, because I in Gen Psych, we're in 8/11, because we're doing some of the mock interviewing, and then we're also moving towards oh, it's gotten thick because of you.
What do you mean?
With the mock interviewing. Oh, I do even more lectures. There's even like cursing involved now, like when I do lectures about workplace survival. Like I added a whole bunch more stuff.
Man, I
From
should-
personality. Yeah, we weren't gonna hire you.
You remember mine?
Oh, yeah.
Yeah.
But you got 3
I
sons.
thought it was pretty confident, but I was just afraid.
Yeah, you went too far. But at least you won't do that when you're actually out there.
Had that in my Gen Psych. It was like all papers, but she's like, please don't like make it all your own original thing. Don't add citations. I don't want to have to read them. So it was just all like our opinions on whatever the chapter was.
Wow, it's not. I wouldn't do that. So in-class activities, 11.3 part B. We're gonna do part B first, because I think it's more helpful. I could change it to part A if that would make it easier for you guys. We'll do that. Edit.
So week 9 one.
We'll make this part A. Or and the week 9 one, yep. And then I'll hide the other ones just so that it doesn't feel overwhelming or difficult. Just go like this. And we'll go hide. I can leave them out there too, but I want to overwhelm you guys. Then I'll just unhide them later. So now it should just be week 9. And then we'll go like this. And go like that. Okay, just making sure that the other person in this course is not texting. Come on, why did that not open? Chapter 9, open. There we go. Okay, cool. All right. Perfect. Okay. All right. So the estimated standard error is an estimate of the standard deviation of a sampling distribution and the sample means of a selected population with unknown variance is an estimate of the standard error or standard distance that the sample means deviate from the value of the population mean stated in the null hypothesis. The T statistic, known as T observed or T obtained, is an inferential statistic used to determine the number of standard deviations in a T distribution that a sample mean deviates from the mean value or the mean difference stated in the null hypothesis. The T distribution or student's T is a normal like distribution with greater variability in the tails than a normal distribution because the sample variance is substituted for the population variance to estimate the standard error in the distribution. The degrees of freedom for a T distribution are equal to the degrees of freedom for sample variance. for a given sample, n-1. Each t distribution is associated with specified degrees of freedom. As the sample size increases, the degrees of freedom also increase. FYI. The degrees of freedom for a t distribution are equal to the degrees of freedom for a sample variance, n-1. That's review. We just talked about that. The t-table lists critical values for 6 levels of significance for 1 and 2-tailed tests. The assumptions for a 1 sample t-test are normality, random sampling, and independence. The 1 sample t-test is a sample statistical procedure used to compare a mean value measured in a sample to a known value in the population. It is specifically used to test hypotheses concerning the mean in a single population with unknown variance. So, example 1, social functioning is the ability for individuals to interact or adapt in a normal or usual way in a social environment. This area of research is of interest, particularly in clinical settings or those study human development. An example for a 1 sample t-test asked the relatives of patients with their obsessive compulsive disorder are as healthy as those in the general healthy population. In their study, they recorded the social functioning of relatives with patients with OCD using a 36-item short form health survey ranging from 0 to 100. They cited the mean social functioning score in the general healthy population of the interest was 77.43. Using the sample data that approximates the findings, we test whether the mean score of the sample data given below significantly differs from the general population. So here's our scores right here. So we state the hypothesis right here. So the population mean is 77.43, and we're testing whether it's equal or not equal to the population mean. So null hypothesis, the mean is equal to 77.43, the same as the general healthy population. Alternative, for relatives who care with it, it's not equal to 77.43, so it's affecting their mental health. Make sense so far for step 1? So step 2, we set the criteria for a decision. The level of significance with this test is 0.05. We are computing a 2-tailed test with n-1 degrees of freedom. With n equals 18, the degrees of freedom for this test are 18 minus 1, which is 17. To locate the critical values, we find 17 listed in table C2 and appendix C. Go to the column 0.05 and the 2 tails combined. The critical values are plus or minus 2.110. Y'all still with me? Makes sense so far? For a graphical representation, what we're doing, you can look at figure 9.2 in electronic text, which can also be found on page 281 of the paper text. The shaded regions represent the rejection regions with the critical values plus equal to plus or minus 2.110 for t distribution with d is equal to 17. If the value of the test statistic falls in the shaded region, we reject the null hypothesis, otherwise we retain the null hypothesis. Does that make sense? We will compare the value of the test statistic with the critical values. If the value is beyond the critical value, either greater than or less than plus or minus 2.110, there is less than a 5% chance we would obtain the outcome if the null hypothesis were correct. So we reject the null hypothesis, otherwise we retain the null hypothesis. Makes sense, right? Step 3, compute the test statistic. In this example, we compute the sample mean and standard deviation for the data given above. So remember from chapter 3, the sample mean is a sum of all scores. And then introduced in chapter 4, not 4n. To compute sample standard deviation, first subtract and square the difference of each score from the sample mean and divide by n-1, and then take the square root of the standard deviation, 20.94. Is that, hang on, that might be one of you texting me to get into Zoom. Okay. Is anyone else having a problem getting the attempts? 6 attempts on WebAssign. Okay, that's really weird. Only one of you is. Okay. So then we will then compare the sample mean to the population mean state of the null hypothesis, mean 77.43. To find the t statistic, we first compute the estimated standard error. How do we get the standard error? Well, to compute the estimated standard error, which is the denominator of the statistic, we divide the sample standard deviation by the square root of the sample size. So standard deviation divided by the square root of the sample size. So standard deviation 20.94 divided by the square root of 18 is 4.94. Does that make sense? just sample error. That's this formula right here. Standard deviation divided by square root of n. Therefore, the standard error is 4.94. Then the t obtained value is mean minus the sample mean minus the population mean divided by the standard error. So 62 minus 77.43 divided by the 4.94 that we just found is equal to negative 3.16. Make a decision, you decide to reject or retain. We compare the obtained value, t obtained value to critical values. Negative 3.126 falls on beyond the critical value in the lower tail. It falls in the rejection region. The decision is reject the null hypothesis. Now, using this following set of data, so the data coming up right here, the same aforementioned scenario, deciding your groups using the same formulas. If this group of 20 people or n is changed, with OCD are as healthy as those in the general population, we use a population mean of the healthy population of interest at 77.43. So walk through the steps and then we'll do it as a class and check your work. And changing the numbers and then doing the math to make it incredibly simple and easy to do, and then we'll do it together. So I'll give you like 5 or 10 or 10 or 15 to do that. You can talk to each other, you can ask me questions, and then we'll do it as a class. I could explain it right now, but I feel if I do that, it may not sink in. So give it your best shot. If you totally go out in left field, it's okay, because we'll do it together in a moment, okay? But like literally, if you scroll up, it should be right there for you.
Dr. Mack?
Yeah.
I was gonna say that I am for chapter 10, the web assign, it was due already. And I was trying to do it this weekend, well, the past weekend, and it wouldn't let me because it was
I can take care of it.
yeah, if you don't mind. And I was wondering for chapter 6 and 7, can you give us up to this weekend, like Saturday? I was just like really sick and I didn't even finish them.
Yeah, I can help you. This chair is really messed up. Hang on.
Thank you.
It's better. Okay. So, well, you guys are working on that. I'm going to just do a screen share. Actually, I have to stop the screen share. So let me go into WebAssign, because I don't want anybody to see
Yeah.
anyone's scores. So give me just a second. So it's chapter 6 and chapter 7. I need to change, right?
Yeah, and chapter 9.
Or talk to me now, everybody else, and I'll add more time. It's okay. Should be. Oh, I can fix that. That's, let me do one thing at a time.
I'll email you about it later.
No, I can, I'll fix that first. Hang on. That's really easy. If the deadline passed, I just need to do an import that takes like 2 seconds, and then I'll fix your thing, Marina. So.
Okay, awesome. Thank you.
Yep. I thought you were saying, Jackie, that like you couldn't get into WebAssign. I got you. Oh, they will right now. WebAssign. Okay, so now go ahead and refresh because they should be there now.
Fine.
Yep, everybody's. I just brought them in.
Okay, now my score.
Yeah, there you go. No problem. All right, so WebAssign 6, you said over the weekend, so that would be helpful, right?
Yeah, just like Saturday midnight.
Just till Saturday?
Yeah, I usually do them for my
I did six is now due on Saturday. Then you said 10 also?
9, no, 9 like this,
Nine.
because I was trying to get ahead on this chapter for web of sign, and it.
Oh, I don't know if
didn't-
I've signed 9 yet, but I can take care of that. That's fine.
Oh,
It doesn't matter. Spot that because I didn't do it yet. Yeah, okay.
Web assign 9. So web assign 9 is now by the 5th, but yeah, that's by the 5th right now. And then did you need me to extend anything else, Marina?
no, that's all. Thank you.
Does anyone, you're welcome. Does anyone in class need me to extend any web assigns? Right, I think Andy was texting me earlier.
Can we take a quick break?
Want to take a break? Yeah. Yeah, I was about to say the same thing. I was just trying to. 5 minutes or 10? What do you guys need? 10? It's fine. Again, it's 4 hours, so, yeah. So 25 after.
And, I remember how I had posted like, if you want to hold on, just follow over the link. So you only-
I gotta either be able to follow the link and I can't read pages.
No,
You should be able to resubmit, and if you resubmit, I'll get a queue to grade them automatically.
I did, I was.
I've graded since that time.
Yeah, this is great.
Maybe
Try to open your link. Maybe I can come up with them. Those are docs and info.
doc should work. Let me see.
Yeah, I never knew.
I don't have an infographic in my queue, so I have one in the main grade book for you. Just resubmit it, and it should come up. It should allow limited resubmissions, and then I'll just run to the restroom quick, and then I'll verify when I come back that it's there. And I'm not screen sharing, so no one's seeing your information.
Okay.
In fact, we'll go like